Hi everyone, welcome back to my channel. I hope you're all doing great. Today I wanted to talk about solving word problems using the trigonometric functions we've been talking about. So these two are just some examples. So the last video I talked mostly about applying the angle of elevation and angle of depression and how that is used in word problems. And now today I'm just going to talk about how to apply those things and also how to apply the trig functions to solve for word problems. So we're basically now just taking those trigonometry functions and just kind of putting it into a picture and drawing it out and stuff and solving it this way. And I don't really like word problems. They're not my favorite, but what really helps me is just trying to pick out the most important pieces that I see. So let's do this first example here. So it says, Jay is part of a bird watching club. He is standing on ground level looking for a bird with his binoculars. And this is a very bad drawing down here. He spots a blue bird in front of him sitting in a tree. If J is a horizontal distance of 13 feet away from the tree and the direct line of distance from him and the bird is 15 feet, what is the angle of elevation? Okay, so I've underlined the most important parts here. So it says he's standing on ground level. That is important because that will determine our angle of elevation. So he is standing on ground level here. So this is just ground level, this bottom leg of our right triangle. And it says he is a horizontal distance of 13 feet away from the tree. So a horizontal distance of 13 feet away from the tree. So that means horizontal, that would be also this bottom leg. So this would be 13 feet away horizontally. Now if it said vertically, it would be going up like this. It would be on this side, but it says horizontal distance. So that means 13, we would just put 13 on the bottom of our triangle. And then it says the direct line of distance from him and the bird is 15 feet. So his direct line of distance, because he's looking up at the bird, he has to angle his elevation. he has to angle his eyes up to look at the bird. Because of that, his direct line of distance to the bird is going to be 15 feet. Yeah, and because he had to elevate his eyes, his direct line of distance to the bird is 15 feet. And then the question asks, what is the angle of elevation? So what we're trying to find here is this angle of elevation right here, this x. And so now we can just apply our trig functions. So here we can use, we're trying to solve for angle x. So we can use, let's see, so this is our hypotenuse, 15 feet, and this is our adjacent side. So we can use cosine, because remember cosine is adjacent over hypotenuse. So we can say cosine of our angle x is equal to our adjacent side, which is 13 feet, over our hypotenuse, which is 15 feet. And now we can just solve. So because we are solving for an angle here, we have to do the inverse of cosine to find the angle. But if you're just finding the side lengths or the side ratios, you don't need to do the inverse, but in this case we do. So we're going to multiply cosine of our angle x by the inverse. We have to do it to both sides as well. So inverse of cosine. So this just leaves us with x here by itself, which is what we want. And now we just put this into our calculator. So you say the inverse of cosine times 13 divided by 15. That is equal to 29.92, but we can just round that up. So for rounding, we could just say, well, actually, we'll just keep it at 29.9 since we can't. The number after that is 2, so we can't round up. So let's just say, so x equals 29.9. So it's very close to 30. So that is our angle. So it's pretty easy to, it's not too hard to apply the trig functions as long as you know how to draw everything out and stuff. And drawing it out will be really helpful. So our angle equals 29.9 degrees. So this is our angle of elevation. And that's what we're trying to find. Now, the second example here is a little different, but we're still gonna apply the same things. So it says Hallie is a pilot, and again we're gonna pick out the important information. So Hallie is a pilot. She is flying 40,000 feet above the ground. As she is flying, she notices some big dark gray storm clouds and decides to land the plane. She looks down at an angle of depression of 10 degrees and spots the runway. Measuring horizontally, how many miles away is she from the runway? Okay, so our important info says she is flying 40,000 feet above the ground. So this is our plane here. So 40,000 feet above, that means vertically. So 40,000 feet above. And she looks down at an angle of depression of 10 degrees. It's another important part. So the angle of depression is going to be when she elevates her eyes downwards. So looking down at an angle of depression of 10 degrees. And it wouldn't be this part though because she's already flying straight. So it would be between the hypotenuse and her direct line of distance. So an angle of depression of 10 degrees. And remember the like interior opposite corresponding angles are congruent. So like this angle is 10 degrees, so that means this angle will be 10 degrees as well. So we'll just put that so that we can solve our problem. And then, and then she spots a runway. So what we are trying to find here is the horizontal distance between where she is at right now and where she will land at an angle of depression of 10 degrees. So x is what we're trying to find, and it's wondering how many miles away she is. Okay, so this is also, so here we have 10 degrees, 40,000. Okay, so now we can use a tangent of our angle 10 degrees because opposite over adjacent. So we say tangent of our angle 10 degrees equals our opposite side, which is 40,000 feet, over our side x, which is what we're trying to find. Now we can just solve. So because x is on the bottom, we have to times both sides by x. So we have x times tangent of our angle 10 equals 40,000. Now to get x by itself again, we want to divide by tangent of 10 on both sides. Very good at writing with this. So divide by tangent for angle 10. And then we have x equals tangent of 10. Okay, now this is gonna look it's kind of scary because we get a really long number, but it's because it's in feet, but we want to convert it to miles. So we get we get 22,685. Let's see, 851 point, let's see, .1. Sorry, hold on. Let's see. Okay, let me do this again. So 22,685.1.2. Round to 0.3. Okay, so this is a really long number, and it's because it's in feet. So we can convert it to miles now because it wants to know in miles. So I'm going to come over here. So in 1 mile, there is 5,280 feet. So because of that, we can divide this long number by 5,280 feet because that's how many there is in 1 mile. So I could say, let's see, write this out again. 1.3 divided by 5,280. And it'll approximately be, let's see, let's divide that out. 851.3. So it's approximately going to be 42.96. So we can round it to 43 miles. Whew, okay. We did it. So it's the horizontal distance is 43 miles away, approximately. So that is how we solve these word problems. Sorry if it was a little bit messy, but I hope this helped a little bit in helping you understand how to apply these trig functions to word problems, and I'll see you in the next video. Bye-bye.